calculation of available rainwater harvesting. We will take some 2 or 3 problems and understand how to calculate volume of water which could be saved in terms of liter for rainwater harvesting. Estimate how much of water you have harvested from a given area. It might be rooftop or a land surface. There are two ways you can calculate the rainwater. If you have constructed any house or structure, what you can do is it can be collected with the pipe and storage tank. Then if it is available in a land, an agricultural land, it might be an open land, what you can do is you can collect the water and it can be filtered by using a sand filter or carbon filter. These two types of filters are there. According to the requirement, you can do it. The calculation of available rainwater harvesting in meter cube. How you can find is multiply rainfall in terms of meter, catchment area in terms of meter square, multiply by runoff coefficient. Note here that all the units are in terms of meter. The rainfall generally we will receive through Indian Meteorological Department. You can visit that website district wise, state wise, and for a monsoon throughout the year cumulative rainfall for a period of 10 to 15 years. The data is available. You can calculating the rainwater harvesting system for a particular house. Now this is being followed according to IS 15797. It is a code book. You can Google it and you can download. This is the norms which has to be followed for calculating the rainwater throughout India. And Bureau of Indian Standards has published this. National Building Code is another guideline which helps us to calculate the available rainwater harvesting system. Now R is called annual rainfall. Example, if it is 80 mm rainfall throughout the year, you can take it as 0.8 in terms of meter. Catchment area, it is taken as A, its unit is meter square. Runoff coefficient, this depends on the surface. One by one I will discuss. Now, here in the code book where I mentioned IS 15797, this code book gives a table 1 which is for a flat roof. Here you can see an example of a flat roof here, a normal residential house. Only ground floor is available here. You can calculate the overall area, that is catchment area of this structure. Now how to find the first parameter annual rainfall is by taking this tabular column which is for flat roof. Here you can see the top of the roof is flat. You can use this table for calculating the amount of water. Say for example, if the annual rainfall is 800 mm, you can take in the x-axis here and the rooftop area. You have to calculate the length and width of the area collected along with this balcony. The total area from the rooftop from 20 to 3000 mm is given. So you can cumulatively add. Say for example, this area is 100 meter square. You can use the graph to calculate the available water. So from 800 to the 100. So wherever it matches, here it will be 64 meter cube of water. The same way, if you have a sloped roof similar to this, you can use this table 2. When I am solving the problem, I will discuss in detail regarding how to calculate the area for a sloped roof. Note that there is a slight difference in area when you are calculating. Here you can see for 100 mm rainfall, the same rooftop area is 20. For the flat roof, the volume of water collected is 1.6 meter cube. For the same way, the sloped roof, you can see for 100 mm rainfall at the same location, you can see for 20 meter square of rooftop area, 1.9 meter cube of water can be collected. So this is a difference when collecting the rainwater harvesting. The sloped roof holds more water. It does not hold the water, or there will be no evaporation loss, etc. Now, how to calculate the catchment area? When you have different kind of sloped roof, you can see an example of this. All the sloped roof have to be unfolded, and during the unfolding you can make it as a rectangular shape. Imagine this as the length and breadth. You can multiply this and add the two rectangles. This will become a single rectangle, and this is the way you can take the footprint of every roof. Note that when the rainfall is falling in the roof, the overall area can be taken. No need to individually calculate the area in a plan. What will be the total area covered? From the plan, you can take it as the catchment area. It might be in semicircular shape also. You can convert it into a rectangle. No need of considering the irregularity of shapes. Now, third thing is runoff coefficient. From where the water drains. See here, there is a two difference of structure here. Low runoff coefficient, and this will give high runoff coefficient. When the water is moving in a urban area, you can see the land is being covered with road. There is a parking lane here, and there is infrastructure constructed here. This kind of a place will have high runoff. Why? Because there is no point of percolation, no point of stopping the water. The rainwater immediately runs off. This kind of structure will be having high runoff coefficient. The RCC roof has highest runoff coefficient from zero point 0.8 to zero point 0.9. Tiled roof. This also comes in if the tiles are laid. Either it might be a parking tile or roof tile. It has a runoff of 0.7 to 0.8. Now, if it is a paved surface, what do you mean by paved surfaces? It is constructed by paver blocks or road construction, waterbound roads, etc. Bitumen roads. These paved roads have zero point 0.6 to zero point 0.8 of runoff coefficient. If the rainfall is falling in a bare land, if it is consisting of either agriculture or vegetation or this kind of forest, the coefficient should be taken as 0.2 to 0.5, where the runoff water will be very less because all the water will be infiltrating inside the soil. There is no stoppage of infiltration, so that all the water is being absorbed by the roots and the plants, and the runoff water will be very less. Hence, you can see the runoff coefficient is also 0.2 to 0.5. Next thing, let us solve few problems and understand this concept. Determine the quantity of rain water harvesting for the given data. Here there are three data given. Annual rainfall is 900 mm, rooftop area is 100 meter square, and it is taken as RCC roof. If they have given, you can assume that runoff coefficient from 0.8 to 0.9. Here it is given as 0.85. In problems, if they are not given while solving in university, you can assume from 0.8 to 0.9. Now, what is the formula we know? Annual runoff, rooftop area into runoff coefficient. You have to multiply all the three. Note that all the three are in same unit. The runoff coefficient doesn't have any unit, but the rest of the two have a unit of meter or meter square. You can multiply, and the total volume of water collected is 76.5 meter cube. Now, for 1 meter cube of volume, you can hold 1000 liters of water. So, if you multiply 76.5 into 1000, 76,500 liters per year of water could be collected by this rainwater harvesting system. Now, generally there will be losses. What are the reasons? First, flush loss, that is when the rainfall is occurring in a rooftop. When the first flush is occurring, the water carries all the dust particles in the roof. So these dust particles are being considered as losses. So it will be taken separately and it will be drained. The losses due to evaporation and leakage, these can be taken as 10 to 20%. Cumulative water is 76,500 liters. 10% loss you can take it, and if you multiply by 0.9, that 0.1 is 10% loss. So you can calculate the total available water is 68,850 liters per year. Now let us take the second problem. If Rooftop area is 100 square meter and rainfall is 1000 mm. The rainwater harvesting potential and available rainwater can be computed. Now, you know that the formula is ARC. A is annual rainfall, which has to be taken in terms of meter. And here it is given in mm, 1000 mm. You can convert it into meter by dividing the 1000. So mm to meter, when we are converting, we are dividing it by 1000. Area of the roof is taken as 100 square meter. Now 100 into 1000 mm divided by 1000. So this is divided by 1000 into 0.8, which will give you 80 cubic meter of water. If you multiply by 1000, you will be getting 80,000 liters of rainwater harvesting. Now, another problem here, you need to calculate for how many people it can serve additionally. So determine the quantity of rainwater harvesting and total number of people can get benefited for domestic usage during dry periods for the given data. Previous two problems only calculated the amount of water can be collected in terms of liters. Now with that water during dry periods, for how many people it could serve for their domestic usage. Given data, SRIT, the location is SRIT Lingapuram in Kadapa district, and building type is residential, commercial or institutional building. The catchment area is given as 100 meter square, which is rooftop, and the runoff coefficient is given as 0.85. These are the given data. You can assume that this is a flat roof, and the average rainfall which is given as 800 mm, which you can take it as 0.8 meter. Generally, water demand, we use water for two purposes. One is for domestic and another one is used for gardening. What are the reasons for domestic usages? What are the different domestic usages are drinking, cooking, washing, it might be cloth washing or vessel washing. For all this demand, you need 150 liters per day per person. Same way for gardening irrigation, you need 200 liters per day. This is also per person. Now, if you add the total demand, this will be 350 liters per day. It is required. So, let us calculate for how many days this rainwater harvesting can be used. The total rainwater harvested can be found as 100 into 0.85 into 0.8, where 100 is area, 0.85 is runoff coefficient, and 0.8 is annual rainfall. So totally 68,000 liters you can collect. So your answer will be 68 meter cube. You can multiply by 1000, it will be 68,000 liters annually. Now, what is the effective water yield? I have earlier discussed that 10% of evaporation loss you can consider. 10% of loss you can consider. Now 0.9 into 68,000, which will give you 61,200 liters after losses. So this is the water which we can collect annually. Now let us come to the second part, for how many days it could serve during the dry days. Now number of days of water availability. So total amount of water which is available is 61,200 liters divided by daily water demand. Our demand for domestic and gardening purposes 350. How many days it could serve is 174 days it could serve. 5 to 5.5 months it can serve. So we generally have monsoon for 5 months, and during the period of June, July, August, September and October. After this period, the rainfall will be very less and you can use this water for dry periods. In dry periods also there are two types of dry period. One is cold dry period and hot dry period. Now, let us find the annual water demand, which is 350 liters per day into 365. So, total water demand here is 1,27,750 liters. Now, the percentage of water demand can be fulfilled is around 47%, nearly 50% of water can be fulfilled by rainwater only. Rest of the water can be used from the bore or from the government water supply. Now, what are the dry seasons I have told? Uh, it could be from November to February. After October, November, December, January, February. These 4 seasons are dry seasons, and rest of the 3, March, April, May, are hot dry seasons where you will be having very less amount of rainfall, and you can use the rainwater during these days. Now here there is a table here which is given month-wise average rainfall. Now this is also available in Indian Meteorological Department, and throughout the year you will be having this data for a particular month. What is the amount of rainfall in the particular district which is available? Now you can tabulate this, and total rainfall available is 877.8 mm. Number of rainy days is also there. And if you add only the monsoon rainfall from June, July, August, September, and October, you can add and see that 650 mm of rainfall, around 75% of annual rainfall falls in only 5 months. So this you can store it. And by the graph you can understand here, this is a example of Bangalore. For Bangalore city, how much of rainfall is available during the different months. Average annual rainfall for 15 years it has been taken. So a cumulative of 15 years January rainfall has been collected, and the range is being given here. Now let us come to water storage and demand analysis here. The dry periods are assumed as 100 days, hot dry period. For that, what is the formula? Is L is the length of dry period. It is taken in number of days. V is the volume of tank in liters. N is number of people using the tank. And G is consumption of liter per capita per day. This you can use it domestic consumption or for gardening purpose, etc. Now you can calculate from the given data. Let us take for domestic usage, it is 150 liter per day per capita. The 100 days are dry days. By using that graph, you can understand that how many months. So nearly 3 months are hot dry days. Now you can calculate by LNG. What are LNG is? L is number of dry days into N number of person into 150 liters per capita per day, which is domestic usage. Total water availability is 61,200. So 4 people can use during this dry days. And you can store this rainwater by using this kind of containers. And 61,200 liters can be stored in this kind of container. It can be used by pumping the system.